Assalamu alaikum wa rahmatullah. Good evening. Today our class is all about the virtual LAN principles. So the objective of this class actually to teach you how to explain the application of virtual LAN tagging and how to describe the different port link types and characteristics, and also how to successfully establish port-based virtual LANs. So we will learn all of this. We will learn about the tagging, virtual LAN tagging, and also we will learn about the port link types and also port link characteristics and what is the difference between these port link types. Also, we will learn how to establish port-based virtual LAN. Okay, before this, we are going to introduce the virtual LAN. So why we need virtual LAN? So at the beginning, we started with local area network only. So then, because of the limitations of the local area networks, many problems happened. Okay, to avoid these problems, we came up to the virtual LAN. Okay, so the use of virtual LAN is only to solve the limitation of the local area networks. Okay, let us start. As local area network expand, traffic increases and broadcasts become more common. Okay, so when the local area network become big and expanded, it will have a lot of switches, and these switches will connect many computers and mobile devices. Maybe mobile devices cannot be connected, but only the normal PCs that can be connected directly to the switches. So for this reason, all switches will become in the same broadcast domain. So if all of these computers are in the same broadcast domain, so we will have the same collusion domain. And also this will cause many scenarios of broadcasting to happen. So broadcast will become very common. So when the broadcast is common in a network, the network will have something called unnecessary traffic because of this unnecessary transmission to many PCs. Broadcast happen when a PC is connected to a LAN and the switches doesn't know, or the switches did not know about the destination of the packet. Okay, so in this case, switches will start broadcasting scenarios. So broadcast scenario, that means every packet will be sent to all connected PCs and to all connected switch ports. So this will consume the resources of the network. So the network will have wastage of resources, and also will have something called delay increase, and also collusion may happen in many cases, and the performance in general of the network will become very bad. That's why, for this reason, they have to, I mean, the designers of networks, they have to do something. Traditionally, they solve this kind of issue by installing some devices that can divide the broadcast domain into small, to break the big broadcast domain into small broadcast domains. So for example, if let's say we have this here, so maybe instead of keeping the same this network in the same broadcast domain, maybe we install one router here to break down this network into two broadcast domains. So this is the first broadcast domain, and this is the second broadcast domain. So if this solves the issue, and the performance is better and we are satisfied, that's fine. But sometimes we do this, then the customer will start complaining again. So maybe we need to replace this device also by router to split this also to subdomains, okay, or broadcast domains. And also maybe this one we replace by router, and also this will create this one a broadcast domain, and this is another broadcast domain. So we see how to break down the big broadcast domain into small broadcast domains. So how to break down this broadcast domain is by installing a layer 3 device, layer 3 network device. Layer 3 network device is like router. Okay, so maybe somebody will tell that, okay, if this is the solution, why we don't do this? So the answer is quite easy. Actually, we cannot install routers everywhere. Why? Because this will affect the performance. This is number one. And number two, also, this will cause a significant increase of the network implementation cost, because router is much expensive compared to the switch. So maybe one router can cost a value of like 3, 4 switches together. Okay, that's why we have to deal with something called virtual LANs. Okay. So, however, here in doing so, that means if we install routers here instead of these switches, the alternative, sorry, in doing so, additional expense was incurred. So the expense of, or maybe the cost of the network implementation will become very high. And also the forwarding behavior of such devices did not provide as efficient throughput as found with switches. So switches can provide better performance, better throughput compared to routers. Why? Because complexity is less compared to the routers, because routers will take the packets or the bit stream from the physical layer and convert it to layer 2 packet or segment. Then after that, from layer 2, it need to be decapsulated to layer 3 and so on. So this is all of this is increasing the complexity. So the delay will increase by nature, and the performance will become lower compared to the switching, because switching, it need only to do decapsulation for the second layer. That's all. Okay. So leading to bottleneck, when the delay or the complexity increase in some points at the routers, so the router will become a bottleneck. So the bottlenecks will become a critical points of the network. So this will cause things to become worse and worse. That's why what they call it, the virtual LAN technology comes to the scene. So virtual LAN can be implemented among switches. So maybe virtual LAN, these two PCs and the other third PC who are connected, which are connected to different switches, are needed to be in the same virtual LAN. So as you can see, this one is connected through totally different switches compared to this two. Okay. Also, these three are connected through different switches, but as you can see the color here, these three are in the same, are needed to be in the same, what they call it, virtual LAN, and these three are needed to be in the same virtual LAN group. Okay, so the principle of virtual LAN technology was introduced to that enable traffic isolation at the data link layer. So at the layer 2, a virtual LAN will add the isolation of data. A new feature will be added to layer 2. And also virtual LAN technology has the added advantage of traffic isolation without the limitation of physical boundaries. This means the limitation of physical boundaries. If let's say we installed router here and router here, we will never be able to make this two together with this BC in the same group because there are physical boundaries. But using virtual LANs, even if the devices are connected through different switches or maybe located in different places, they can work together as one virtual LAN group. Okay, so users can be physically dispersed but still be associated as part of a single broadcast domain. So this one is a single broadcast domain. Even though they are located in different places, but they are still in the same broadcast domain. So logically, the virtual LAN logically is isolating users from other user groups at the data link layer. So everything, this isolation will be done at the layer 2. So the complexity will not increase similar to the layer 3 devices. Today, virtual LAN technology is applied as a solution to a variety of challenges. So the virtual LAN can solve many problems. We will learn them along this class and the next class also. So let us continue to the other slide. Okay, here, in this slide, we are going to learn about the virtual LAN frame format. So as I explained before, any feature you need to do, it will require something to be added in the bucket header. So here for the virtual LAN feature, we have to implement something called virtual LAN frame format or frame header. So here in this slide, we have two types actually of virtual LAN frames. The first type is virtual LAN frame, which is untagged frame, as you can see here. Untagged frame, this one. Okay. And the second type is the tagged frame. So the first one and the second one has a little bit differences. So as you can see here, the destination MAC address is the same, source MAC address is the same, also type is the same, data also is the same, and FCS are the same. The only difference is the existence of the tag or the utilization or the use of the tag in the second type. So these things, destination MAC address is very clear, is the MAC address of the destination device, and the source MAC address is the MAC address of the source or the sender device. And here is the type of the frame. And this is the carried data through this frame. And here is some flags. Regarding this tag, the tag has how many fields here? It has 4 fields. So the first field, this one, is the TP ID, and the second one is the PCB, and the third one is the DEI, and the third one is the virtual LAN ID. Okay, let us go and see how these fields are explained. So if you can see here, we have this and this part, two main parts. The first part is 2 bytes. This one, the TPID, is 2 parts, only one field of 2 bytes. And the second field, the second part here has 3 fields, 1, 2, and 3. And also this second field is only 2 bytes. So the second part has the PCB and DEI and the virtual LAN ID. Virtual LAN ID, as you can see here, is 12 what they call it, bits. Okay, so the virtual LAN frames are identified using tag header, which is inserted into the Ethernet frame. So this tag header will be inserted into the Ethernet frame. So this one is an Ethernet frame, normal Ethernet frame. If we use the normal Ethernet frame, then the frame will be untagged. But if we insert the tag field into the Ethernet frame, then the frame will become tagged. So identified using a tag header, which is inserted into the Ethernet frame as a mean of distinguishing a frame associated with one virtual LAN from frames of another. So when we use tagged frame, then the frames will be differentiated, will be easily distinguished. Why? How they can be distinguished? Because of this tag. Because this tag includes the virtual LAN ID. So any switch will know this bucket or this frame belongs or coming from what virtual LAN. Okay, the virtual LAN tag format contains a tag protocol identifier, the TPID. So this one is an identifier of the tagging protocol. An associated tag control information, which is the TCI. The TPID, which is the tag protocol identifier, is used to identify the frame as a tagged frame, which currently only refers to the IEEE 802.1q tag format. So this is the standard number, the standard of the virtual LAN number. So please remember this, because this can come to the exam. So if the question asks you, what is the IEEE standard number for the virtual LAN, you have to use this value, for which a value of 0x8100 is used to identify this format. So this value 8100 is used for this standard, for the standard of 802.1q. Okay, then later we have, what do we have? We have the TCI. TCI contains fields that are associated with the tag format. Okay, so TCI contains fields that are associated with the tag. So the first field is the PCB, this one, and the second field is the DEI, and the third is the virtual LAN ID. So from here, we will understand that this one, this one is what they call it TPID. And this part is called TCI. Okay? So the TCI part has three fields: PCB, DEI, and virtual LAN ID. Let us go first to the what they call it, to the PCB. So priority code point, PCB, is a form of traffic classification field that is used to differentiate one form of traffic from another, so as to prioritize traffic generally based on a classification such as voice, video, or data. So based on this definition for the PCB, we understand that every type of traffic, for example, video, will take a PCB code. So if, let's say, video is number 10 and voice is number, for example, 9, and normal data is number, for example, 7. So 10, 9, 7. So here it depends on the value and depends on how it works. So the higher the value is, the higher the priority, or the opposite way. So we have to learn that. So here we use the PCB field only to differentiate or to classify the traffic inside our network, to give priorities for real-time applications like video and voice. Okay, for more details, this is represented by a 3-bit value, allowing a range from 0 to 7. So this one is only 3, is only a 3 bits. 3 bits, like this. Okay, and the value can be from 0 to 7. Okay, let us understand, and can be understood based on general 802.1p class. So this is another standard 802.1p class. This is another standard for the priorities, for the, what they call it, class of surface principle. Okay, so let us go to the next field here, the drop eligibility indicator. DEI, this one. DEI, so this one. Drop eligibility indicator presents a single bit value. It's only one bit. So this bit exists in either a true or false state. So this represents the value of true or false. So the true or false state to determine the eligibility of a frame for discarding in the event of congestion. So if, let's say, this one is true, that means we allow this packet to be discarded in case of congestion. But if false, that means this packet is very important and it cannot be discarded even if we have a congestion. Okay, so this one is very clear, I think very simple to understand. And the third field, which is the virtual LAN ID, is how many bits? Is 12 bits. So 12 plus 1, 13 plus 3 is 16. 16 bits means 2 bytes, as we explain here. TCI is 2 bytes. Okay? Okay, the virtual LAN ID indicates the virtual LAN with which the frame is associated. So when we find, for example, in a certain frame, the virtual LAN ID, for example, is 10, that means this frame is coming from virtual LAN number 10. So this represented as a 12-bit value. 12-bit value. So you can imagine how many fields, how is the maximum value allowed for the what they call it, virtual LAN IDs. So here, if let's say we take let us take the programmer. Then we take binary. We take this value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this value, as you can see, is 4095. 4095. So here, as you can see, the maximum possible virtual LAN combinations can be 4094. 4094. Why 4094, not 4095? Because the virtual LAN 0 is the standard. Virtual LAN 0 is the default. That's why it's excluded. So we can start from 1 until 4094. Okay, so here the range is starting from 0x00 through to the 0xFFF in hexadecimal, which is from 0 to 9094, and for which two upper and lower values are reserved. So we have two values are reserved. The value number 0 and the virtual ID 4095 is what they call it, reserved. So the number of possible virtual LAN combination is only 4094. So Huawei VRP implementation of virtual LANs uses virtual LAN 1 as the default virtual LAN BVID, as based on IEEE 802.1q standard. Sorry, I mentioned that the VLAN, the default of the virtual LAN ID is 0, while it's 1. I'm sorry about it. So we have number 1 is the default virtual LAN ID. So virtual LAN ID can be shortened as BVID. BVID. Okay, that's all about this slide. Let us go to the next slide and see the link types. Link types. So in general, in the virtual LANs, we have two types of links. Two types of links. The first type is access link. The second type is trunk link. So the first type, actually access, is the link that's connected from the switch to the end system. So this link, and this link, also this link, with this link, with this link, all of them are access links. Also, this one can be access. This one also can be access. This one also can be access. And this one also can be accessed. But this one is a trunk link, okay? So this is the main concept of the link types in the virtual LAN. So a trunk represents a backbone for the transmission of virtual LAN traffic between switches. Okay, so here, in this case, the trunk link will allow the traffic between switches that belongs to different virtual LANs. So the different virtual LAN traffics will be allowed to travel or traverse the trunk link, while the access link will allow only the traffic from the same virtual LAN, only from the same virtual LAN. So let us read the comments here. Virtual LAN links can be classified in two types. Also, here they will repeat the same thing. So the first type is the access link type, and the second is the trunk link type. The access link refers to the link between an end system and also a switch. So any link between an end system and the switch will be considered access. Okay? So what's about this one and this one? Later we are coming to explain about them. Okay? So here, the condition that we have to define the access link type is that this link, access link, is a link that's established between end system and switch device, participating in virtual LAN tagging. Participating in virtual LAN tagging. The link between host, terminals, and switches are all access links. As I explained, all of this are access links. What's about the trunk? A trunk link refers to the link over which virtual LAN tagged frames are likely to be carried. So here, you can see that the trunk link refers to the link over which virtual LAN tagged frames are likely to be carried. So here, the traffic here in the trunk link will be tagged frames. But here is untagged. Untagged. Sorry, double G. Tag is double G. Okay, so at the trunk link, the buckets or frames will be tagged, but at the access links, the carried frames will be untagged. I don't know why this one shows up here. So this one will be untagged, which is traveling through the access links. So the link between switches are generally understood to be trunk link. So also these links here are likely to be trunk links. Are likely to be trunk links. Why? Because the traffic here is needed to be tagged as well. Because if let's say this is a virtual LAN 2, so if a packet comes from this PC here, going through this routers, I need to clear, I think, all of these things. If let's say a packet is coming from here, going through this path to this PC, so this packet here will carry the virtual LAN ID number 2. So the PC doesn't know about the configuration of the virtual LAN. So the virtual LAN is only configured at the switch level. So when the packet come here from this link, the switch will put the tag of virtual LAN 2. Then the packet will be transmitted to the other switch as tagged packet that includes the virtual LAN ID number 2. Then this switch should send it to the other trunks here and here. Okay. Then this packet here will be transmitted also to the other switch as tagged. So this one is tagged. Here is tagged. Here is untagged. Okay. But when the packet arrives here at the final switch that's directly connected to the destination, then the packet will be sent here to the destination as untagged. So you can see here, all of the access links are carrying the untagged packets, while all the trunk links will carry the tagged packets. Why they need to carry the tagged packets? Because they need to differentiate and they need to know how to deliver these packets. So a trunk link refers to the link over which virtual LAN tagged frames are likely to be carried. The links between switches are generally understood to be trunk links, but sometimes we have different configuration, and later you will see how to use what they call it, the trunk type. Actually, we have also hybrid. We have access and trunk, and also we have hybrid. But later you will understand when we need to use hybrid, for example. And I'm not sure whether it's explained here or not. Yeah, hybrid is already here. So let us go to the port virtual LAN ID first, then we go back to the port times again. So here for the port virtual LAN ID, which is PVID, it represents the default value for each interface. So this value, PVID, will be configured at the switch level for every interface, for every port interface. So the PVID is set to virtual LAN 1 for all ports by default. So if we don't configure the PVID for all interfaces, they will be belongs to the virtual LAN number 1. Each interface of a device participating in virtual LAN tagging will be associated with a virtual LAN. The default virtual LAN for the interface is recognized as the port virtual LAN ID, PVID. The value determines the behavior that is applied to any frames being received or transmitted over the interface. So this value, actually the PVID, will determine the behavior that is applied to any frame being received or transmitted over the interface. So based on this value, the switch will decide either to transmit or discard, receive, forward, or not, what to do. Everything is going to be decided based on the value of the PVID. And again, the PVID have to be configured for every interface separately. So if you want to put port number 1 and port number 2 on switch number 1, for example, this one, this switch is switch number 1, and we want to make this port belongs to virtual LAN 2, and this port belongs to virtual LAN 2 also. Then in this case, we have to go to the switch number 1 here, and we have to go to the interface, for example, this one, interface 0, and we assign PVID 2. And then we have to go to this switch, we go to this interface, we assign PVID 2 as well. Okay? This 2 here still belongs to PVID 1, which is the default value. Why they keep the default value here? Because this one is the trunk. Okay? So based on this configuration here, we can see that these two belongs to the same virtual LAN, and these two belongs to the same virtual LAN. So traffic is going to be sent through the trunk link. Okay, I'm going to, I want to explain more here. That's why I need to clean. So this, as I explained, these two BCs, again, these two BCs belongs to the same virtual LAN, and these two BCs belongs to the same virtual LAN. So as you can see here, this packet will need to send data through this path, am I right? So here, this traffic is from virtual LAN 2. And also this BC will need to send data through the other switch for the other BC that belongs to the virtual LAN 3. So here, this one is virtual LAN 3. So as you can see here, the trunk is required to allow traffic from different virtual LANs to be traversing the trunk. So here for the trunk, for this scenario trunk configuration, we are going to allow traffic from virtual LAN number 1, virtual LAN number 2, virtual LAN number 3 to be traversing the trunk link. Okay? Okay. Each interface of device participating in virtual LAN tagging will be associated with a virtual LAN. The default value for the BVID is number 1, BVID number 1. So the value determines the behavior. So the behavior of the transmitting, forwarding the packet or discarding it depends on the BVID. Okay. Okay, let me go to this slide. The port type access. Okay. So here in this scenario, as you can see, we have 3 interfaces. So the first interface is this one, belongs to virtual LAN number 2 and number 10, and the other one belongs to virtual LAN number 10, and the third one belongs to virtual LAN number 2. So if let's say the main problem that was solved by the VLAN in this scenario, if let's say we want to send the packet from here to from here to unknown destination. So the switch here is going to do broadcast, am I right? It's going to do broadcast. But because this packet is going to be tagged inside the frame, so inside the switch, the packet will be tagged by number 10 here, by number 10, as you can see. Okay, so number 10 is the tag of the virtual LAN source. So even if a broadcast is going to happen inside or in this switch, the broadcast will be done only for the ports that carry the same virtual LAN ID. So in this case, the packet will be only sent to the host C, and it's not going to be forwarded to host B. Why? Because host B is connected through a switch port which belongs to different virtual network. Okay, I hope this is clear, and let me show you the other things here. As you can see here, the packet that's generated from the host A here and sent to the switch through the access link, access link, actually is an untagged frame. Why? Because the PC has nothing to be configured for the virtual LAN. The host itself doesn't know what virtual LAN ID that's it participating in. Okay, so they don't know in which virtual LAN they are belonging. So here the packet will be, or the frame will be unframed, but when it goes through the switch, it will be tagged. Framed by the original virtual ID, by the original virtual LAN ID. But after that, when the packet is going to be forwarded through another access link. So the access link, the port of that's connected to the access link is going to untag the frame. So the number of 10 is going to be removed, and the frame will be sent as untagged frame. Okay? So access ports remove virtual LAN tags before forwarding frames. So access port do two main tasks. So as you can see here, we have two access ports. So this access ports, if the packet is coming from an end system to the switch, so the port will add the tag to the frame. But if the packet is leaving the switch towards the end system, so the access port is going to minus the tag. Minus the tag. Tag is going to be removed. Okay? So when the packet is coming to the switch, the tag will be inserted. When the packet is going to leave the switch towards an end system, the tag is going to be removed. So to summarize, or to summarize the thought that we was explaining, actually the access link cannot send any tagged frames. So all frames that can go through the access links must be untagged. Okay, let us go and see the other type of trunks. Actually, here we have a lot of comments. Just go through them and read if there is any extra information. But the main idea is what I have explained just now. Okay, for the trunk type, as we agreed here, as we agreed in the previous slide, all access links will carry the untagged packets. But when the packet is coming to the switch, the virtual LAN ID will be inserted. So inside the switch, all packets will be tagged. Am I right? Tagged packets. And also inside this switch, all packets will be tagged as well. So if, let's say, this switch need to send data to this switch or the other side, the packets here can be put tagged or untagged. Depends on the configuration and depends on the scenario. Okay, let me clear this. And let me explain to you why sometimes we send untagged and sometimes we send tagged. Okay, so if you can see here, this port is virtual LAN ID 10. This one is also 10. This one is also 10. And this one is also 10. So all of this network belongs to the same virtual LAN. So when the traffic is going to the same virtual LAN from here, the source of packet and the destination of the packet ports, the source port and the destination port, if the two ports belongs to the same virtual LAN, then the port is going to untag the frame. Okay, so that's why the frame will be untagged. So here, the untagged frames inside this link, untagged frames belongs to virtual LAN 10. Belongs to virtual LAN 10. Okay. What's about the other virtual LAN? This is virtual LAN 20. Virtual LAN 20. So if the packet comes to the switch here, the tag 20 will be added to the frame. Then when the switch want to forward it from here to here, so it will find this one is virtual LAN ID 20 and this one virtual LAN ID 10. So it belongs to different networks, So if this link is an access link, the packet will be discarded. But because this link is a trunk link, the packet should be allowed to travel the trunk. Okay, so here this packet, sorry, that comes from 20, the virtual LAN 20, and needs to go through a link that belongs to virtual LAN 10. It has to be kept with the tag. It has to be kept with the tag. So the tag is not going to be removed, because if the tag is removed from here, then this packet is going to be delivered to wrong hosts. Okay, because if the packet is untagged, if this one is untagged, then it comes through the switch. This port is belongs to virtual LAN ID 10. Then the tag 10 will be inserted to this frame. Then the packet should be forwarded only to ports that belongs to the virtual LAN 10. So it will be delivered to the wrong destination. That's why the tag in this case need to be kept. But in the previous case, it's supposed to be removed. Okay, that's all. The concept is very simple, but somehow tricky. So we need to understand the tricks of the virtual LAN in order to be in the safe side. Okay. This one, actually, this scenario of the trunk ports actually supports the two types of frames, which is tagged and untagged, to be traveling in the trunk link. But in the second scenario, or the third type of ports, which is the hybrid actually is supporting the tagged packets only. So even packets that's coming from virtual LAN 10 actually is going to be kept with the tag when it's forwarded to the trunk link or to the hybrid link. Okay, so this one is a hybrid link. The hybrid link actually can be used for the trunk and also can be used for the access. Okay, as you can see here, hybrid untagged and hybrid tagged. So when we use the hybrid port type, we have to decide, is it tagged or untagged? So it can be tagged when we use it with the end systems. Okay, but with the end systems, it will be untagged. But with the, or among the switches, it have to be tagged. So in this case, all packets that's going to be traveling through the this link is going to be tagged. It's going to be tagged. This is the only difference. So hybrid ports are defined as either tagged or untagged. Virtual LAN communication can be managed on a port by port basis. So the virtual LAN is going to be configured in the switches only. Okay, computers are not involved in this configuration. Okay, let us go to the next slide. Okay, virtual LAN assignment methods. So here, if let's say we have switch A, and switch A is connected to host A, B, C, D, and here are the IP addresses. So host A is 10.0.11, host B is 10.0.2.1, host C is 10.0.1.2, host D is 10.0.2.2. So based on this IP addresses, we will understand that these two belongs to the same virtual LAN, and this two supposed to be belongs to the same virtual LAN. Okay, so sorry. Let us see the table here. The first one, actually, we have the assignment method, and we have virtual LAN 5, and we have virtual LAN 10. So the assignment method for the port-based, okay, we have actually more than one method for assignment, because we need to go to the switch and we assigned the port to the virtual LAN. So this is one assignment method. So we assign the port to the virtual LAN. The other assignment method is to use the MAC, address. And the third assignment method is to use the IP subnet based, IP subnet. So for example, we can say that virtual LAN 5 is involving only packets from this network, and virtual number 10 including only packets from this subnetwork. Okay, and for the previous scenario, for the MAC based, we can list the MAC addresses that belongs to a certain virtual LAN. And also we can assign a protocol to a certain virtual LAN. So in this case, in the third scenario here, we can say that the IP or maybe TCP belongs to virtual LAN 2. Voice over IP belongs to virtual LAN 3. And maybe what they call it, other type of protocols we assign to virtual LAN 6, 7, 8, whatever. Then based on the assignment of virtual LAN to every protocol, we can differentiate between them in order to give them priority. So here we will get the benefit from the classification done based on the virtual LAN. And also the other assignment, or the last assignment method, is the policy based. So policy based, it can be a combination between multiple things like IP subnetwork and physical interface, also MAC address. So this is much more complicated, and it's needed to be used in advanced scenarios. So port-based virtual LAN assignment is the default assignment method. So the default assignment method is the first one, but we still have 4 types of assignment methods. So together we have 5 types of assignment methods. Okay, guys, hope this thing is clear. Okay, let me clear the screen. A lot of text here, please go and read it by yourself. I already explained the main concept of the assignment method. Later we will see how to use that. Okay, let us now go to the scenario of creating the what they call it, virtual LAN scenario. So here, if let's say we have this scenario. I don't know why they did not explain about the virtual LANs here, because the virtual LAN IDs are not clear. Okay, let us read. Maybe there's some explanation here. The implementation of virtual LANs begins with the creation of the virtual LAN on the switch. The first thing we have to do is to go to the switch itself, then we can create the virtual LAN. So in this command here, create us the virtual LAN number 2. And also after we create the virtual LAN number 2, it would take us to the interface, virtual LAN interface view. Then after that, if let's say we want to do some configuration for virtual LAN number 10, we can write the command straightforward here. Otherwise, we have to quit to go back to the main view. And also the other way of creating virtual LANs, we can create them by batch. So maybe we need to create on a certain switch, for example, switch A, we want to create virtual LAN 1, 2, 3, 4, 5. So in this case, we can use the command virtual LAN batch 1, 2, 5. 1, 2, 5. So this command will create the virtual LAN number 1 and virtual LAN number 2, virtual LAN number 3, virtual LAN number 4, and virtual LAN number 5 using only one command. So as you can see here, this operation may take a few seconds. Please wait for a moment. Done. So after this, we will see that the virtual LAN 2 and 3 are created. So this is how to create the virtual LAN. So we have two types of commands. The first type is to create a single interface, a single virtual LAN, and the other one is to create virtual LANs as patch. Okay. Let us see the next thing. So here, after we create virtual LANs, we can use the command display virtual LAN. Let me operate my NSP to explain to you clearly. So maybe it could be much better. Okay. So let us take switch, for example, this and this. Let me operate them. Okay, let me use connection between this. Okay, GA001, GA001 also, and oh, this blocks everything for me. Okay, so now we have to wait for the startup to finish. Okay. So now the switch number 1, if let's say we want to create virtual LAN number 2, for example. So we have to be in the system view. So in this case, we can say virtual LAN 2. Okay, so now we already created virtual LAN 2. So what if we display VLAN? Display VLAN here, we can see this one is virtual LAN number 1. It involves all of these interfaces, interface 1, 2, 3, 4, 5, 6, 7. All of these interfaces belongs to the virtual LAN number 1. Why? Because the virtual LAN number 1 is the default for all ports. But interface virtual LAN number 2 here is still not, doesn't involve any interface. So we have to go to a certain interface, then we assign that interface to the virtual LAN number 2. Okay, now in here, we are not going to assign an interface to a certain virtual LAN. Now here we want to learn how to create the virtual LAN itself. So, okay, the first way is to create a virtual LAN, certain virtual LAN, only single virtual LAN by its number. For example, like this, virtual LAN number 2. So you can see here that virtual LAN number 2 is already created. What if we want to create virtual LAN as patch. So if let's say we want to create from 5 to 10, we want to create virtual LANs from 5 to 10. Okay, now this may take blah, 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 done. Okay, what if we display now? Display virtual LANs. So you can see here virtual LAN number 1, which is the default. This one is the one that we created by a single command. And this 5 virtual LANs are created by single command, by only one single command. This one, virtual LAN patch 5 to until from 5 to 10. So 5, 6, 7, 8, 9, 10 will be created. So here we can see that we have many virtual LAN interfaces, but we don't have any physical interface attached to them. Okay. Let us go and see the other slides. So this is how to display. The other thing is setting the port link type, setting the port link type. So in here, we are going to choose some interfaces inside the switch to be assigned for a certain interface. But before that, we have to decide the port link type. We have to decide the port link type. Okay, let us go to this scenario. Let us connect one PC here, other PC here, one here, one here. Then let's say we link them like that. Okay. So in this case, we have 4 PCs connected. Let us start them. So everything is green now. And now for this switch, we have already created how many virtual LAN? We created virtual LAN 2 and virtual LAN 5 to 10. So we have together about 7 virtual network interfaces. Okay, so if let's say we want to assign this port GE001 to be a trunk port. So in this case, we have to use the command port link type trunk, port link type trunk. Okay, let us go here. So we are still on switch number 1. Before we assign the port type, we have to go to the interface itself. 001. So this interface, am I right? So if let's say this interface, we want to use it as port link type, then here we have trunk. Okay, so this one is trunk. Let us put some notation here, trunk. Okay, and all of this are no fill. Sorry, dash it. Supposed to be access. Okay. So the first link we already assigned. The first port is already assigned the port type as a trunk port. Okay, what's about the other interfaces? Interface. gigabit. Let me interface Ethernet. 001. So this interface is also needed to be the port type, link type need to be assigned. So here we can say access for the interface. This one we assign the link type as access, and after that we go to interface number 2, and we assign the link type as access. So until now, we decided the port link, the port types of the interfaces, but we did not assign the virtual LANs. Okay, we did not assign virtual LANs. Okay, let us do create some annotations also here. Dashed color is green, for example. Okay, then here we assign, oh, I deleted this. So here device is already switched off. I have to start up the device again. Then I have to configure the things again. Okay, sorry for that mistake. So here before this, undo terminal link, then system view. Okay, what I want to do is this one. These two belongs to virtual LAN VLAN 2. And this one is VLAN 3. This one is VLAN 3 as well. Okay, let me go and do the configuration now for you to show you how it works. I'm going to shift this a little bit. Okay, now the configuration for the switch number 1 is to use the to create the virtual LAN 2, and also we need to create virtual LAN 3. Am I right? So we need virtual LAN 2 and virtual LAN 3. So we already created both of them. What's about switch number 2? Here I use the command for a single virtual LAN creation. But for this here, I'm going to undo terminal link first, then system. And here I'm going to create virtual LAN patch 2 and 3 as a patch. So you can see both of them can be used. So here in the first switch, I use the single command for every virtual LAN. Here I created virtual LANs as patch. Okay, the second thing, I have to go to an interface gigabit Ethernet 001, and I'm going to say to this port link type is trunk. Okay, and after that I quit. I go to interface Ethernet 001. I want to make it access. So here I use this command. Instead of trunk, I use access. And after that, I go to interface number 2. This one here. This one is access. This one is also access. And also I assign type access. Okay. I should go also to switch number 3, to switch number 2 also. I have to go to interface gigabit Ethernet 001, and I have to assign port link type trunk. So this port is also trunk. This one is trunk, and the other side is trunk. And now I need to go to Ethernet 001 and Ethernet 002. I have to make them access. Okay, so here interface Ethernet 001. So here the port type is access. Then I have to go to interface number 2 and also assign access. So here we are. The configuration until now is going smoothly. We now still missing one part. So we have now this 3 interfaces, and these 3 interfaces are still belongs to the virtual network ID number 1 by default. So here we are going to learn how to change the how to assign the BVID. So the BVID actually is going to be assigned using this command, port gigabit Ethernet, for example, 007, inside the virtual LAN view, So in our case here, so we have to go to switch number 1, and we go to virtual LAN 2, okay, 2 or 3, no problem. For virtual LAN 2, we are going to assign the interface Ethernet 002. Okay, so here we say port Ethernet 002. So here we are, it's already assigned. And now we need to go to virtual LAN 3. And virtual LAN 3, we are going to assign the port Ethernet 001. So port Ethernet 001. Okay, that's all. Assign it. And for this port is already by default is assigned to virtual LAN number 1. Okay, if you want to check, so we can display virtual LAN. So you can see here the virtual LAN that we have is 3. One is created by default, and it includes all of these interfaces. And number 2 is created, and number 2 and number 3 are created manually by me. So virtual network number 2 includes interface Ethernet 002, and virtual LAN number 3 includes the interface Ethernet 001. Okay, let us go now to this interface, to this switch. If let's say we display VLAN, we will see that the virtual LAN 2 and 3 are there created, but the interfaces, all interfaces are still belongs to virtual LAN number 1. Why? Because we did not assign any interface to any virtual LAN. So, okay, let us go to virtual LAN 2. So virtual LAN 2 is going to be assigned to the Ethernet 001 should be assigned to this. Ethernet 001 should be assigned to virtual LAN number 2. And after that, we have to go to virtual LAN number 3. We assign port Ethernet 002. Okay, let us display now again. Okay, quit first, then we display virtual LANs. We can see here the virtual LAN number 2 includes interface 001, correct? Virtual LAN number 3 includes the interface 002. So we always need to confirm after we do configuration. We need to check whether we create the correct configuration or we mistakenly did something wrong. So we have to always do a kind of verification after every setting, or maybe after we finish every device. We can go through the entire configuration, then we check whether we make it correctly or wrongly. Okay, so now if let's say we want to assign some IP addresses here. So let's say we use 10.0.1.1 here. Okay, subnet mask is 255.0.0.0.0 and so on. Okay, so here 10.0.1.1. Am I right? 10.0.1.1 and 255.0.0.0. Okay, what's about this? This actually this PC belongs to virtual LAN 3. Okay, and this PC belongs to virtual LAN 3 should be using the same IP addressing group in order to be able to communicate with the PC number 1. So also here we have to use 10.0.1.2 and 255.0.0.0. Okay, let us configure this. Okay, 10.0.1.2, 255, that's all. Apply. Okay, if we Bing now, if we use Bing, so Bing is this. Oh, sorry, command. So Bing 10.0.1.2, it's supposed to work, but still is not reachable. Okay, so this PC has an IP address which is from the same network as BC number 4, but BC number 1 and BC number 4 cannot communicate because both of them are connected to different switch. Okay, to different switch, but the different switches are connected using a trunk link. Am I right? But this trunk link actually is allowing the traffic from the virtual LAN ID number 1 only. Why number 1 only? Because these two interfaces belongs to virtual LAN number 1. Okay, let us make it here, because I want to make it simple here to make it clear. Okay, this one is VLAN 1. Okay, So the traffic here is only allowed this trunk is only allowed to pass through the traffic from virtual LAN number 1 only. That's why this BC number 1 and BC number 4 cannot communicate. Also, BC number 2 and BC number 3 are not able to communicate. So here we need to use 10, 0. Oh, here we use 20, 0, 1, 1. And here we use 20, 0, 1, 2. Subnet mask is 25500, 255000. So this is going to be used for BC number 2 and BC number 3. Okay, let us configure this. 20. I just want only to show you how this thing is not going to communicate also. So this one is 1, and here we have 255. That's all. Close. And the other PC also is going to be 10, oh sorry, 20, 0, 1, 1, and also here 255. Okay, if let's say we take this BC2 and we ping BC3, 20, 0, 1, 2, it's also unreachable. Destination host is unreachable. So why unreachable? Because this traffic actually belongs to virtual LAN 2, is not going to be allowed to pass through the trunk. So here, what we missed to configure actually is port default virtual LAN 3. Okay, here in this slide they show two types of assigning an interface, physical interface to a virtual LAN. So you can go to the virtual LAN view, then you can use the port, then you follow the name of the interface to be assigned to the virtual LAN. The opposite way is to go to the interface itself. You can go to the interface itself. Then from the interface view, you can assign the virtual LAN. So you can use either way, this way or this way. Both of them are correct. So inside the interface, you can assign the link type or the port type as access or as trunk. Then you can assign the virtual LAN number. Okay. After this, we have to check, as I explained. So they use the display command. But after that, we have to forward, we have to allow the data to be forwarded over the trunk. So here, the trunk, two sides are already defined as a trunk, and they are belongs to virtual LAN number 1 by default. We are not going to change them, but we need to use this command, port trunk allow pass. Okay, so here, in the switch number 1, we have to go to, we have to go to the interface itself, GE001. So interface gigabit 001. Then here the command is, as you can see, we should use port trunk allow pass. So here, port trunk allow pass. So what kind of virtual IDs that we need to allow? Actually, we need to allow virtual LAN 2 and virtual LAN 3. Allow pass 2 and 3. Is it like this? 2 and 3 without and. So 2 space 3, like that. So, oh, sorry, we did a mistake here. We have to write VLAN. So port trunk allow pass VLAN 2 and 3. Okay, so 2 and 3 are allowed. Okay, if we did one side and the other side is not allowing, then we still cannot ping. We still cannot ping. You can see here because we have to do the configuration on the two switches, otherwise it's not going to work. So, okay, here we go to interface on switch number 2, interface gigabit Ethernet 001, and we also use the port command, port trunk allow pass VLAN 2 space 3. So after we finish this, if we go here now and we check this, so we can see that BC number 1 can access BC number 4. Okay, this is BC number 4. The IP address 10012 is the IP address of the BC number 4. It's accessible. Okay, what's about the BC number 4? Can ping 10.0.1.1? Yes, it can. Okay. What's about pinging BC number 2? Ping 20.0.1.1. Destination host is unreachable. Why unreachable? Because this one belongs to different network. Because it's totally different subnetwork. Am I right? That one here is 10.0.1.1, but this one is 20.0.1.1. Anyhow, even if this one belongs to the same network, let us make it 10 also to show you what is the difference between using virtual network and normal networks. So here, this two actually 10. Sorry, I'm going to use. I differentiate them with this. Okay. So this one is 2. They are still from the same network. Okay. So all of these IP addresses belongs to the same subnetwork. Why? Because the subnetwork here is 255.0.0.0. This means only the first octet is the same. And here the first octet is 10.10.10.10. So all belongs to the same subnetwork. They're supposed to be accessible. But if we have virtual LANs, then they will not be able to communicate unless they belongs to the same virtual LANs. If they belongs to the same virtual LANs, then they can communicate. Okay, so let us go back here to BC number 4. Okay, and we use ping command 10.0.1.1. It's accessible. Why? Because both of them belongs to virtual LAN 3. But if we ping BC number 2, even if BC number 2 is from the same subnet mask 0.2.1, it's not going to be accessible. Destination host is unreachable. Why unreachable? Because the host BC2 belongs to different virtual LAN. What's about BC number 3? BC number 3 also unreachable because it's also belongs to different virtual LAN. Okay, let us go to BC number 3. BC number 3, and let us ping BC number 2. These two BCs belongs to the same virtual LAN. So here you can see both of them can communicate. So this is BC number 3 can ping BC number 2, and also BC number 2 can ping BC number BC number 3. 10022. Is it correct? Oh, this one is 22. Okay, so let us check again. So this BC3 can request timeout. What I have did, I think I did wrong configuration. So this one is 10022, correct? 10022. This one is 10021, correct? So what's happening here? Maybe it takes time. Okay, let us check this. It works. So BC4 can communicate with BC1, but I don't know why BC3 cannot. Now it communicates, because I think because this one is simulation takes a little bit time. So BC3 can communicate with BC2, and also BC2 can communicate with BC3 here. And both of them cannot communicate with BC number 1. And also cannot communicate with BC number 4, because both of them belongs to different virtual LAN. So here we are. That's all about the virtual LAN. Here is how to display the virtual LAN on the switch A. So you can see the results if we run this command. Now, after we configure the trunk, we can display a VLAN. So here we can see that the VLAN total number of virtual LANs is 3. So 1, 2, 3. This number 1 is the default, includes all of these interfaces. Number 2 is only this. You can see here the letter U. Letter U means untagged. Okay, untagged, because this one is untagged. This one is untagged. Ethernet 0, untagged, Ethernet 0. Oh, yes. Yes, you can see here, this virtual LAN number 2, actually it involves only the Ethernet 001 here. Am I right? Ethernet 001. As what? As untagged. Why untagged? Because this one is access. And also it involves the GE001, because we, at the trunk, we allow virtual network 2 and 3. So also this GE001 will be a part of the virtual LAN number 2, but as tagged interface. Okay. For the interface, for the virtual LAN number 3 also, here, we are on switch number 2. Here, the virtual LAN number 3 is including or involving Ethernet 002, as you can see, as untagged here. As untagged, why? Because this one is an access link. And the GE001, this one as tagged link. Okay, so that's all about the configuration. Forwarding here, we have to display virtual LAN to see the things, as I explained just now. And after this, if we want to configure hybrid port, if we want to configure hybrid ports. So we can use the port link type hybrid, then port hybrid BVLAN. We assign it to a certain virtual LAN. Then after that, we decide whether it's untagged or tagged. Okay. So here, if let's say we want to change. If let's say we want to change the interface, or sorry, the configuration from the access and trunk to hybrid. So here we have to configure the hybrid here for these two interfaces first, and these two interfaces first. Then after that we go to the trunk, and we change it also to hybrid. So here first we go to system view at the switch number 1, and we go to interface Ethernet 001, and here we have to use port link type hybrid. Then we use port hybrid. Sorry, I sometimes forget also. Yeah, port hybrid BVLAN, BVID. Yeah, it's correct. Hybrid, correct. Oh, the auto logging is very miserable. This is the interface. Port type is hybrid. Please renew the default configuration. Error. Why error? Because we already have the configuration. Okay, the best thing is actually to switch off everything to reset the configuration. I'm going to reset everything, then I start up. So when I start up, all configuration is going to be lost. Only IP addresses that we assigned to the PCs are still there, fortunately. But here inside the switch, because switch number 1 and switch number 2 are restarted, so the configuration is already lost. Okay, undo, terminal logging, then system. Okay, let us test here. If we configure, if we ping here, ping 10.0.1.2. So from PC number 1, we ping PC number 4. Oh, what happened? Maybe it needs time. If the configuration is there, so display VLAN. We don't have any configuration for the virtual LAN. Okay, they're supposed to be accessible. Yes, now it's accessible. It needs time. It needs time for the virtual machines to be up, to be started up. So BC4 is accessible. What's about BC2? BC2 is also accessible because we don't have virtual LANs, and also all of these IP addresses belongs to the same subnet work. Okay, so before the configuration of the virtual LAN, everything is accessible. I don't know why this every time it goes back to the standard. Okay, system view, then VLAN patch. We are going to create VLAN 223. Okay, okay, it's already created. Then here system view. Okay, so here we create also VLAN patch 223. So also created. Here we have to go to interface, the first interface, Ethernet 001, and we have to mention that the port link type is hybrid. Then port hybrid VLAN. This port number one. This port number one should be assigned to virtual LAN number 3. Am I right? So what's wrong with this? Oh, we forgot to mention tagged or untagged. So this one is supposed to be untagged. Am I right? Untagged VLAN 3, because this one is access port. Am I right? So we have to make it untagged. Okay. Let us now go to interface number 2. Then here we also put the link type as hybrid. Then after that, we have to make it untagged, but belongs to virtual LAN number 2. What's about the GE? GE interface. Let us quit. Interface GE001. So it's supposed to be port. I'm not going to rewrite the commands. This one is hybrid, but the type of the interface supposed to be tagged and belongs to virtual LAN number 1. Okay, and also here we need to allow later. We need to allow the traffic. We need to allow the traffic. Okay, let us now go to switch number 2. We go to interface Ethernet 001 port link type hybrid. Then we use port. What is the command? Port hybrid. Yeah, port hybrid. This one must be untagged, also untagged VLAN. This one is interface number 1, supposed to be belongs to virtual LAN number 2. So here we go to interface number 2, and also we assign the port link type to hybrid. Then after that, we make it untagged port belongs to virtual LAN number 3. Then after that, we quit interface gigabit Ethernet 001 for this interface. Also, we have to configure it. And also here we have to make it link type hybrid, but for the tagged or untagged, this one is tagged. Tagged virtual LAN belongs to virtual LAN number 1. Okay, let us now check BC1. Is BC1 accessible to BC4? Let us check 1, 2. Yes, accessible. Okay, and what's about BC3? BC3 is accessible also. What's about BC2 is also accessible. So what happens here? It looks like it doesn't work properly. Okay, let us see. So we assigned the link type as hybrid. Then we assigned the interfaces as tagged or untagged. Okay, before we do troubleshooting, before we do troubleshooting, we have to go to the switch itself. Then we display VLAN. Display VLAN. Okay, so here for virtual LAN number 1, you can see here the GE00, this one, actually is going to be tagged. Okay, and for virtual LAN number 2, you can see here untagged for interface number 2, and virtual LAN number 3 untagged for interface number 1. So, okay, let us explain here what is going to happen when we ping from BC1 to BC number 3, from BC number 1 to BC number 3. So BC number 1 will send a packet to here. I will draw something for you to understand. So the packet will be sent from here as untagged, but here inside will be tagged with 3. Then after that, it's supposed to be tagged as 1. And after that here, it will be tagged with 1. Then after that, the switch supposed to send it as untagged. Okay? Okay, let us see how it can be fixed. I will see whether they have fixing this or not. So here, port link type hybrid. So we have to go to the gigabit Ethernet hybrid, and instead of port hybrid tagged virtual LAN 2 to 3, we run the command virtual LAN 1. So we wrongly did the configuration here. If you can go back here to interface gigabit Ethernet 001, we have used this command actually. Am I right? So here we need to undo this. Undo. Use the command tagged virtual LAN 1. We need to undo this. Then after that, we need to use port link type hybrid tagged port link type hybrid. We already assigned this. Then port hybrid tagged virtual LAN 2 and 3, because we need to tag the data from virtual LAN 2 and virtual LAN 3, not data for virtual LAN number 1. Am I right? And also for this, we have to go to gigabit Ethernet this one, and instead of this command, we are going to undo this command, and we have to use this command, but instead of interface virtual LAN 2 and virtual LAN 1, we use virtual LAN 2 and 3. Okay, let us test now. Okay, this computer is BC1. We try to ping BC2. Unreachable. Why unreachable? Because it needs time. Let us check again. It will take a little bit time. Still unreachable. Takes time. Destination host is unreachable. Still unreachable. From PC1 to still unreachable. Okay, it works now. Oh, doesn't work. Let us check again. Still unreachable. I don't know what is wrong we have done. So if we quit from here, let us display VLAN. So here we can see for interface for virtual LAN number 2, we have untagged Ethernet 001. Ethernet. Oh, this one is switch 2. Switch 2. Virtual LAN 2, we have Ethernet 001 untagged. And also we have tagged GE001 for virtual LAN 2. So this is supposed to be okay. So what's about the virtual LAN 3? Virtual LAN 3 actually involves the 002 as untagged. And also it's supposed to involve the GE001 as tagged. And also for this one, display VLAN, it involves for virtual LAN 2, here 2 is this, involves the 002 as untagged and GE001 as tagged. Okay, so this is correct. And also for virtual LAN 3, it involves untagged link with the interface 001 and tagged link for the GE001. So all of these are correct. So what's about this here? Hybrid, what we have done here. So we configured this untagged for interface number 5. For interface number 7. Yeah, that's fine. We have done this. What's about the configuration of hybrid ports? For this port, we have assigned the link type hybrid. And then after that, we make the virtual LAN 2 and 3 tagged. So everything's supposed to be okay. Then after that, display virtual LAN. So everything is until now okay. Configuring hybrid ports. Hybrid ports can be configured to receive virtual LAN traffic from multiple virtual LANs by simply removing the tag at the port interface. Okay, this one actually is for this interface. If let's say this interface, we need to receive all traffic from every PC. So in this case, we have to remove the tag from virtual LAN 2 and virtual LAN 3. Yeah. I remember what's wrong with this. So here we still cannot reach this interface, this PC. Why? Because this interface, Ethernet 002, Ethernet 002, it's supposed to port hybrid untag. It's supposed to untag VLAN 3. Okay, so any packet coming from virtual LAN 3, it's supposed to be untagged. Okay, if we check now, I don't know what's wrong with that. Okay, let me check this also. So here, untag. I think we have to make it also here. So this one, it need to put untag. But we already done this actually from the beginning. We already done this from the beginning here. Yeah, we already done this from the beginning. So it's supposed to be correct. Configuration, we have already received all of this. Hybrid ports. Hybrid ports can be configured to receive virtual LAN traffic from multiple virtual LAN interfaces. Remove the tag. So this one is what? Display VLAN. Okay. I don't know what's wrong with it. Our configuration is correctly done actually, but I don't know what's wrong with that. Okay. So let us capture data here on interface G001. This is an advanced topic actually to be done. So here we are going to run the Wireshark on the interface 001. So we will see what happened to our data. Is it arriving to the interface, then after that dropped or not? So let us ping now. And we see here, there's no data. There's no data here. Okay, stop and quit without saving. Okay, let us capture data here from interface number 1. Here we see how this data is getting into the interface. So if we ping, you can see here broadcast. That's fine. What if we capture data here on GE interface? Then we ping. Okay, so the packets are already dropped here inside this switch. So what if we ping 22? Also the same thing. So it seems that we configure this we configure these packets to be this ports wrongly. Okay, what we have done here, we went to interface, interface, keep it Ethernet. Yeah. Then we run this command. Port link type is hybrid, exactly as we have done here. Exactly as we have done here. Port link type is hybrid, then after that tagged virtual LAN 2 and 3. So this one is in virtual LAN 3 and 2. So what's wrong with it? I don't know. Port hybrid tagged, yeah, correct. So what's wrong? I don't know what's wrong with it. So link type is hybrid. Tagged virtual LAN 2 and 3. So everything's supposed to be fine. Anyway, this scenarios can happen in many times over the simulation, but believe me, the configuration are correct. So now what I'm going to do is, sorry, I'm going to save, yes, and yes. Okay, then after that, I'm going to switch off. The problem actually with the simulator is always when you switch off, then you switch on, then you do multiple configuration on the same topology, that may cause a lot of problems. That's why I prefer always to use different topology when we have different scenarios. But this is my mistake from the beginning. I hope that we still have our configuration on. And here, 10.0.1.1. 10.0.2.1. 10.0.2.2. 10.0.1.2. Yeah, correct. So everything's supposed to be fine. So here we have to go to system view. Then after that, this. Okay, the untagged 002 for virtual LAN 2 and tagged 001 virtual LAN 2, correct. Then this one virtual LAN 3 includes untagged 001 and tag the trunk. Okay, this is correct. Okay, let us check. Enable, 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 everything is enabled. Okay, system view. Then here, display VLAN. So here in switch number 2, virtual LAN 2 is untagged for this interface 001 and tagged for the GE 001, and for the virtual LAN 3 it's untagged for the 002 and tagged for the 001. Okay, it's supposed to be fine. Let us now test. We changed nothing actually. It's still not working. I'm not going to waste more time with this, but for sure it's supposed to work, but I don't know what's going on. Okay, we had the same configuration, exactly similar to this results here in the slide. So it's supposed to work. Okay, configuring hybrid ports. So hybrid ports can be configured as untagged for multiple interfaces for multiple virtual networks. So for example, this one belongs to virtual LAN 2, and it needs to receive also traffic from virtual LAN number 3. So in this case, we have to use port hybrid and tagged virtual LAN 2 and 3 on this port to allow this PC receive traffic from virtual LAN 2 and virtual LAN 3. So this part will be, this PC will be participating in virtual LAN 2 and also participating in virtual LAN 3 at the same time. So this configuration can be done only using the hybrid port. With the access port, we cannot use that. So this is one of the advantages of the using the hybrid link type. Okay, so this one is all about the voice virtual LAN applications. So in this case, if let's say we want to use a different assignment method. Okay, let us go back to the assignment method here. So assignment method default is based on the port. As we have configured all of the previous scenarios, we did the configuration based on the port. We go to the port itself, we assign it to the virtual LAN. But if let's say we want to use configuration for protocols, then we have to use the assignment method of protocols. Okay, so to avoid any mistake, I don't want to repeat the same mistake with this scenario. I need to create a new scenario. I'm not going to save that one. And then we have to put switch, another switch, and also VIB, IPTV here, and voice over IP here. Then here we have the MAC address. Here we have also the MAC address. Okay, let us see whether to. I think no need to create a scenario on the simulator. I just explained this here on the slide, and you will understand how it works. So virtual LANs are used to distinguish, isolate, and prioritize voice traffic over surface traffic as a means of quality assurance. So in order to guarantee the quality to the customer or to the user, you have to do what they call it quality of service. Quality of surface configuration. So the quality of surface configuration need some virtual LAN configuration to give priorities for the VoIP and for the IPTV as well, because these two applications are real time and the delay is not acceptable in these two applications. So maybe file transfer, we delay the file transfer packets, then we allow the VoIP and IPTV packets to be delivered first. Okay, so here I'm not going to read all of this. You can go through it. You have nothing to explain. Actually, it's very clear because I already explained in the previous slides. Here, what we have to do is to go to switch number P, switch P here, and we, for example, create virtual LAN 2. Then we go to interface 001, this one, and we create what they call it voice virtual LAN 2 enable. Voice virtual LAN 2 enable. Then we can use the command voice virtual LAN mode auto, then quit. After that, this is only to assign this interface to the voice virtual LAN 2 using these two commands. Then after that, we have to be at the main view. Then we can use this command, voice VLAN, which is this. We include the MAC address of the VoIP device. So here you can see 0011-2200-0000. So here Y0, because this one is MAC address, I mean, anything belongs to this range. When we say 0, that means anything belongs to this range. So this one have to be fixed, 0011-2200. Then we can accept 0001, 0002, 0010, 0020. Anything from this range can be acceptable. And also the subnet mask is going to be FFFF-FF000000. So it's only to mention that this part, the last six numbers can be changed. So anything, any MAC address that have this similar first six parts, then it will be acceptable. It will be forwarded through the voice VLAN link. Okay. Here we can display the voice VLAN status. Then we can see the VLAN ID is 2, status is enabled, because we already enabled here. Am I right? So the status should be enabled. And here the aging time is this, and standard is 802.1p, and DSCP is 46, and so on. And also here the interface is auto. Okay, so this one is auto, and the security mode is security. Here legacy is disabled, and so on. So that's all about the voice over IP configuration with the virtual LAN. So here we comes to the last slide, which is the summary. So if a trunk link has a BVID of 5 and the command port trunk allow pass virtual LAN 2 and 3 is used. So if let's say on a certain interface, the interface is assigned to virtual LAN 5, but we run this command, port trunk allow pass virtual LAN 2 and 3. Which VLAN traffic will be carried over the trunk? So as you can see here, the traffic that will be allowed to be carried over the trunk is the traffic from virtual LAN 5, 2, and 3. Okay? Virtual LAN 5, because 5 is going to be allowed by default, and 2 and 3 are going to be allowed by this command. Okay, what action will be taken by an access port with BVID of 2 when receiving an untagged frame? Okay, if an access port assigned to BVID 2 receives an untagged frame, it will tag the frame with the number 2. Okay, an access port configured with a BVID of 2 will tag all received untagged frames with a VLAN2 tag. This will be used by the switch. This will be used by the switch to determine whether a frame can be forwarded via other access interfaces or carried over a trunk link. That's all, guys, about the virtual LAN. As I mentioned, virtual LAN is very nice, very, actually, I like this topic. Very beautiful topic, very easy to do, but as I mentioned, it's somehow tricky. So in order to do that, we have to take a piece of paper and we have to sketch everything before we start configuring. We have to write the things that we need to do on a paper before we start configuring. Otherwise, we may get lost. So maybe we end up with a scenario that cannot work. Okay. And also for the scenario that we have configured just now for the hybrid link, I'm sure our configuration is 100% correct, but because this one is a simulation, it happens many times, even for us during the lab last time. So sometimes we need to restart the simulator and so on. But I'm sure the configuration is correct because configuration is very easy. For the first scenario, we configured using the access ports and the trunk ports. It works very smoothly. It doesn't show any problem. Okay, guys. See you, inshallah, for the next class, inshallah, soon. Assalamu alaikum wa rahmatullah.